Hello everyone, let's take a look at section 7.3 partial derivatives. In applied count 1, you learn about derivatives of single variable functions. Now we learn about partial derivatives. These are the derivatives for multivariable functions. And we need a very specific way to find the partial derivatives of multivariable functions. That is, if you have more than one variable, you have to pretend that one of the variables is a number or a constant, and then you're going to take the derivative with respect to the other variable. Now let's take a look at an example of how to find a partial derivative of a multivariable function. Consider a function. I have f of xy equal to 50x times e to the 3y plus 5x squared plus y. And I ask you to find partial f partial x and partial f partial y. So when you find this partial f partial x, that means that you have to find the partial derivative of this multivariable function with respect to x. That means you have to treat the variable y as a constant in this case, right? You can imagine y is an actual number like 2 or 3. And then you just going to find the derivative of the variable x only. So in this multivariable function, the first term 50x times e to the 3y, you have 50 is a constant and e to the 3y is also a constant. These two numbers multiply with x, so therefore the partial derivative of this first term with respect to x is 50 times e to the 3y. Now for the second term, this is a little bit easier because you don't have any y involved. So therefore the partial derivative of the second term with respect to x is just 10x. And the last term, because y now in this case a constant, and the derivative of a constant by itself is 0. So the derivative of this term is 0. If you just eliminate 0, this is what you get for partial f partial x. Next, we need to find partial f partial y. So in this case, you're going to treat x as a number. Like once again, you can imagine x as an actual number like 2 or 3, and then you have 50 multiplied with that number or that constant. You have 50x times e to the 3y. Now y is the one that you need to care because this is the partial derivative with respect to y. So 50x is a constant, so it stays the same because it's multiplied with e to the 3y. You apply the constant multiple. And the derivative of e to the 3y is 3 times e to the 3y. In the second term, you just have 5x where you don't have any y. But because you're taking partial derivative with respect to y, and remember we treat x as a constant, so therefore the second term now becomes a constant. So the derivative of a constant is 0. And the last term, once again, because you want to take the partial derivative of the function with respect to y is a variable, and the derivative of y is actually 1. If you get rid of 0, you get 150x times e to the 3y plus 1. I get 150 from 50 times 3. So this is the end of the example. Not only that we have partial derivative with respect to x or partial derivative with respect to y, we also have second order partial derivatives or second partials. So from the multivariable function f, you can have partial f partial x, you can have partial f partial y. And then from partial x, whatever you got after the partial derivative, you're going to find the partial derivative with respect to x again from this function, and partial derivative with respect to y from this function. Similarly, after you get partial f partial y, whatever you got for the function, you're going to find the partial derivative of the function with respect to x and partial derivative of the function with respect to y. One way to check your work is that the mixed partials fxy and fyx, they have to be the same at the end of the differentiation. Now let's take a look at the example. Consider the function g of t comma y equal to t squared over y squared plus e to the 4t squared y minus ln of t. Then I could ask you to find the first and second partials. For multivariable functions, it's easier to find first and second partials when you rewrite a fraction as multiplication. That is t squared times y to the minus 2. That means I bring y squared from the denominator to the numerator. And the other two terms are going to be the same. Now for the first partial, I need to find partial g, partial t. That means we're going to treat y as a constant, and we're just going to look at the variable t. And the derivative of t squared is 2t times y to the negative 2. Now for the second term, you have to apply chain rule. Chain rules say that the derivative of the composition function is equal to the derivative of the outside function multiplied with the derivative of the inside function. In this case, the outside function is the exponential function, and the inside function is 4t squared times y. Now, the derivative of the exponential function is just the exponential function itself, so that's why you have e to the 4t squared times y. And then you multiply with the derivative of the inside function is aty. Because the inside function is 4t squared y, and we need to find the partial derivative with respect to t, so y is the constant. That's why you just look at the variable t. And the derivative of t squared is 2t. That's why you have 4 times 2 times t times y. Altogether, you have 8ty. And for the last term, the derivative of ln of t is just 1 over t. So that is minus 1 over t. As I mentioned earlier, it is easier to find partial derivative when you bring the variable in the denominator to the numerator. So that is 2t y to the negative 2 times e to the 4t squared y times 8ty minus t to the negative 1. Next, I'm going to look at the same multivariable functions I get earlier. And I want to find the partial derivative of this function with respect to y. So remember, now we take partial derivative with respect to y. T is the constant. Because t squared, even though it's the constant, it is multiplied with y to the negative 2, and y is a variable now that we need to find the derivative. So that is the derivative of the first term is t squared times negative 2 times y to the negative 3. And for the second term, we're going to apply the same chain rule concept. That is the derivative of the outside function multiplied with the derivative of the inside function. So that is derivative of the outside function e to the 4t squared y multiplied with the derivative of the inside function 4t squared. The inside function, one more time, is 4t squared y, but we want to find the partial derivative with respect to y, and the derivative of y is just 1. So that's why the inside function 4t squared y, the derivative of that becomes 4t squared. And for the last term, you don't have anything related to y. So that's why the derivative of ln of t becomes 0. Now, if you rewrite this right-hand side expression and drop the 0, you're going to get negative 2. You can bring this in front. You can leave it like this if you want. But in this case, just for the purpose of the video, I'm just going to bring negative 2 into the front. So you just find the first partial. Now let's move on to the second partials. For the second partial, from what I have earlier for partial g, partial t, I'm going to change the color of the middle term because now not only you have chain rule for e to the 4t squared y, you have to apply product rule as well. So I'm going to use a blue color and the red color here to separate the two functions e to the 4t squared y with aty. The product rule, I have the function u multiplied with v. The derivative of that is equal to u prime times v plus u times v prime. Here I want to point out that the first term and the last term in g sub t are easier to find partial derivative. But for the middle term, e to the 4t squared y, I denote it as u. And for the term aty, I denote it as v. Now, let's find the second partial with respect to t. So the first term, y is a constant. That means you have 2 times y to negative 2 because the derivative of t is just 1. And the derivative of the last term is going to be minus, you have the minus in front here, of minus t to negative 2. Now for the middle term, it's a little bit more tricky. You have to apply product rule. Right? You need to find u prime, and this is the function u. You have to apply chain rule for the function u. So that is the chain rule for function u. The derivative of the outside function is just the exponential. The derivative of the exponential function stay the same. Multiply with the derivative of the inside function, which is aty. Now you multiply with v. I'm just going to follow the formula here. Plus u times v prime. V in this case is aty. And v prime with respect to t is ay. Now let's move on to the next second partial. Now from g sub t, I'm going to use this function to find the partial derivative with respect to y. That means t is a constant now. So the partial derivative of the first term is that of 2t times 2 times y to negative 3. Right? Because we need to take a look at y variable only. And 2t becomes a constant in this case. And the last term, because there's nothing related to y for the last term, the derivative of the last term is going to be 0. Now for the middle term, once again, you have to apply product rule. U times v, derivative of that is equal to u prime times v plus u times v prime. So u prime, in this case with respect to y, is equal to e to the 4t squared y times 4t squared. Remember, this is with respect to y. Then multiply with v plus u times the derivative of v prime. Once again, in this case, this is the partial derivative with respect to y. So derivative of v with respect to y is just at. Now from g sub y, g sub y equal to negative 2t squared times e to negative 3 plus e to the 4t squared y times 4t squared. The first term is easier to find the partial derivative. But for the second term, once again, you have to apply product rule. And product rule is u times v prime equal to u prime times v plus u times v prime. Now I'm going to change the color for the second term, just to make sure that you can follow the notation u and v. And you're going to take this function and find the partial derivative of this function with respect to y. In this case, t is a constant. So you have negative 2t times negative 3 times y to negative 4. And for the second term, once again, you have to apply product rule. That is u prime. The derivative of the outside function is e to the 4t squared y, and the derivative of the inside function is just 4t squared, times v plus u times v prime. Why is that 0? Because for the term v, there's nothing related to y. But you want to find partial derivative with respect to y, so therefore the derivative of 4t squared is going to be equal to 0. Next, we're going to use the same function g sub y and find the partial derivative of g sub y with respect to t. That means y is a number now, y is a constant. The derivative of the first term is negative 2 times y to negative 3. And for the second term, once again, you have to apply product rule. U prime times v plus u times v prime. There's a lot to take in for this example because you have to find first partials and then second partials. But hopefully with the color coded, it can help you understand how to find partial derivatives a little bit easier. So this is the end of section 7.3. Please always let me know if you have any questions.